Okay.
I forgot to record it. Okay, so I have inserted the slab, and then you can see the slab here. If I click on this drop down, these are different edge conditions. Okay, so this is
Yes, sir.
two adjacent edges that are discontinuous. Please, you need to have this knowledge, but you already have the idea of what I'm saying.
Yeah, I already have the idea.
All right, good. This is two adjacent edge that is discontinuous. So I'm going to click on, so I will check based on what I have here, which one fits in with this. Okay, so I will just come here, and number 4 is actually perfect for this. Okay, but I think is perfect, but the other way around, because this one that is showing you shaded by that side is telling you that it continues there.
Continuous.
But at this side, it discontinuous. So if I click on this, that is why you have angles here. Okay, so you can change the angle to whatever angle you want. So if I want to rotate this one now, okay, is it 180 or 360?
1, 2. I think it's 270 because you're not going total 360.
I just want to rotate this. So whichever way I rotate this, these two.
Yeah.
If I rotate this way, it's 90. If I rotate this way, another 90. So 180.
Okay, 180.
So because this panel is actually a square panel.
Yeah.
Square. So all the sides are equal. All the panels here, all their sides are equal. They are all 3 meters by 3 meters.
Yeah.
Yes. So if I type in 180, I click on update. That's all. So you can do that for all the panels here. All I need to do is just to click on this panel, click on properties, and I will change the condition. This one now, it continues everywhere, but it discontinues at this side.
Right.
So I will not take it for all of them, since you already have an idea of that. So I think this one.
Number 3, you are going to.
Number 2 and 3
or 2. Yeah.
But I have to rotate it. So number 3 fits into this. So if I'm rotating this way by 90, I think 90. I don't know if I'm correct. All right, just get the basic. So I have one edge that is discontinuous. The other edges are continuous. Okay.
Yeah.
I'm supposed to go clockwise direction, not anti-clockwise. Right? So if I'm going anti-clockwise, this is 90, 180. So I'm supposed to go clockwise is this way. I'm supposed to go 90. So I think I'm correct. Sorry, clockwise is this direction.
No, I'm saying that.
My head is full.
You are doing
Clockwise is this direction. I'm supposed to go this way.
Yeah.
So this is clockwise. If I'm to go anti-clockwise, it's just for me to type in minus. I can type minus 90.
90, yes.
So just do that. That's the same thing you do for all the panels. Okay, you specify their end conditions. Okay, so you specify all of that. Once you are done with that, then these beams, you are most likely going to have walls around those beams. So we are going to include our wall loads on this our beam. So it's just for me to select one of this beam, and I will right click, and I will click on edit wall load, and I will click. Now you can see it's asking me the wall thickness. So I'll type 0.23, that's 230 mm, but you can see the unit here is meter, so that is why I'm putting it in 0.23. Then the height of this building is 3 meters based on what I specify. So you check from the architectural drawing, what is the height? Yes. So the height that was specified by the architect is what you impute. Then the units, wall unit weight. Okay. These values are also in that book by Victor Oyenuga. Okay. So you check all of these values. You are going to see for partition, for finishes, for wall, all of that, they are very much available there. So please lay your hands on that book. Okay, so I'm going to use the value of 3.4. Then you can see it has generated this dead load automatically. If I reduce the value, you can see the value has changed also. Do you understand what I'm saying? If I make it 3.4, you can see it's 9 kilonewton per meter. If I remove the 4, it's giving us 10.2 kilonewton per meter. So the value is changing as I'm changing this. So it's doing that calculation for you. You don't have to punch from your calculator and do all the maths yourself. All right. Another good thing is you can create an opening for this. So, you know, in walls, you cannot have all the walls that are fully closed. You are definitely, some of them you have windows around area, doors. You have doors around areas, some areas you have windows, okay, and all of that. So I'm going to just assume that I have an opening here, and then that opening is actually okay, is 1,200 by okay, sorry. Here is 1,200. That's the size of this window, 1,200. While my X direction, you can do it from your calculator. Just punch 4,770 minus 1,200. What do we have? Divided by 2. I have 1,785. So from here to here, 1,785. So it's just to centralize it. Then from here now to this place, I want it to be at least 900. So my Y, 900. So I have centralized this window at the center of this wall. So I'll click on OK. So you do that for whatever you want to do. Whether you want to create an opening for a door or an opening for a window or whatever opening. Sometimes it's just an opening, you are not fixing a door or anything there. So whatever opening based on what it is, what is in the architectural drawing. Okay. So you click and I'll click on OK. So if I rotate this now, you are going to see that opening in this wall. Are you seeing that opening here?
Yeah.
Are you seeing it?
Yeah, I can see it.
All right. I will click on this beam that has the wall and I will right click and I will click on copy wall load. And then I can come to filter even without filtering it. If I highlight on all of this and I click on paste and I click yes, it's going to paste the wall entirely on all the beams. So what you will do is you cannot have opening everywhere the same. and it's not all the walls that you have opening. Okay.
Yeah.
So let's assume I don't have an opening in this one. Let's say I don't have an opening in this wall. I can click on that wall and I'll right click and I'll click on edit wall. I'll click on edit opening. And then this opening now, I'll turn it to 0 here. Sorry. I'll just delete this. So I've deleted the opening and I'll click on OK. So you can see this wall, I don't have an opening in this wall anymore. So you can repeat that for as many. Instead of even pasting that wall on all the beams, you can just check any of the beam that has the same kind of wall with the first one, you can paste it there. So it's flexible, you play around with it. You are modeling, that's why it's called modeling. You are modeling to fit in exactly what you have in the architectural drawing. But you know, you must have done your general arrangement. General arrangement is structural layout. You know what general arrangement is?
Yes, I do.
So I'm assuming this to be my general arrangement, because you are not going to collect the drawing exactly the way the architects give you and begin to design exactly.
Yes.
You delete the walls, you delete the windows, you delete the doors, you close all the openings and all that. General arrangement is a different knowledge on its own. It's something you need to understand. If you understand it, it's a plus already for you. All right. Yeah. So right now, as it is, we are done with our modeling. Okay. So if I come to my analysis right now.
That's for the first floor.
For the entire design, I'm done with modeling. Okay. The entire design, I just want to assume I'm done with the modeling. Okay. You know, like I said, all these walls cannot have opening. But if I said I want to do this by closing all the opening and all that, and it will take a very long time to finish that. The main thing is for you to understand the concept behind it. And I believe you understand the concept now.
Yeah, I do.
So that's the concept behind that. So I'll come to building, I come to analysis, and I'll come to building analysis. Under my building analysis, I'll click on edit material. When I click on edit material, I'll click on concrete columns. Okay, these are grades. We have concrete column, we have the grades here, and then we have the reinforcement bars here. If I click on this grade of concrete, this one is grade for steel. This one is for concrete. So if I click that of concrete, I will just select 20/25 and I'll click on OK. So let's assume I want to use 20/25 for all of them. I believe you understand what the grade of concrete is.
Yeah.
So I want to use 20/25. And then my grade of steel. Sorry, I'll go back here. Instead of selecting all that manually and be picking one by one, okay? Even from here, you can edit that. But then, here I'm going to use 410. 410.
I thought we use 460 in Nigeria.
Huh?
I thought it's 460 though. It's conventional grade.
Well, it depends on so many designs I see these days. People use 410, some use 460. That's the characteristic strength of your steel.
Yes, because the steels obtainable in Nigeria presently, they are,
you said?
You know, the standard of our steel in Nigeria, they are very questionable. Like Eurotherm, what is this other one? They are all very questionable. So it's better for you to just use something that.
I understand what you are saying. You can use, that's why you are the engineer now. Like all this now that you're talking about, you have to put all of this into consideration. You get it?
Yes.
That's why even your links, it is customary to use Y10. Don't use Y8.
Yes,
okay?
yes.
But the design can provide Y8 for you. So in your wisdom, you use Y10. Because by the time you use that vernier caliper to check the diameter of that reinforcement, you discover it's not even up to that Y10.
Y10, yes.
So even the Y8, if you go and buy Y8 in the market, you discover the thickness is not up to that 8 mm. So in your wisdom, you consider all the Nigerian factor now. You understand? That is why you are the engineer. You are at liberty to play around with it. That's why you must also know what you are doing. So I'll click on OK. So I understand when you are doing your design, you can consider all the Nigerian factor. Just take your time and put all these things in order when you want to do your design. As a matter of fact, there are places I think I heard of that I think in Kano or where they use Y10 for slab. I am telling you, they use Y10. My friend was telling me that in 10 years to come, the massive collapse of building that they will start realizing in Kano is not going to be a small one. Because if you see the kind of blunders they do, it's funny. It's funny. Even the Lagos, I believe you are in Lagos. They do a lot
in Abuja.
Okay, you are in Abuja. Oh, okay.
Yeah.
Okay.
Yeah, in Lagos, the other collapse that happened earlier in the year that eventually killed the developer because he was busy running his mouth and boasting that. Yes, he was busy boasting that
you see
doesn't
some
even
of those
follow.
this thing. Sometimes some of those buildings they don't even do design for them. They just call an iron bender. Iron bender will just say, this is how we used to do it. Like this. He will just use his past experience from whatever he must have done before. They don't know that building are not the same. They don't understand all of this. The same reinforcement you are using for a span, or the same spacing you are using for a span of 3 meters, you still want to use the same spacing, the same thickness of reinforcement for a span of 6 meters. So you see, you are definitely most likely going to have issues. So if you do all of this, arrange all of this properly, just make sure you change all of this based on the grade you want to use. You are at liberty to use the grade you want to use. Okay. That is why it's important you run all these tests, all these, you're supposed to run all these concrete tests, the steel tests and all that. But most places they don't do it. They don't do most of these tests, honestly. They just go into construction without testing the mix and all that. It's unfortunate. So if you do all that, you come to your project parameters. Here you can see, I think I selected Eurocode.
Oh, you selected BS 8110.
Sure? Why am I seeing Eurocode? Well, okay, these are all the available codes.
BS 8110. Yes, 8110. Oh, I just.
Did you see it?
Load. Yes. Go back. Yeah.
Yeah.
Yes.
I'm looking for it. I can't find it.
BS 8110 UK. That's the fourth row.
Sorry. Yeah, exactly. BS 8110. Yeah. That's what I was looking for.
Yeah.
Okay, this is for steel. Okay, so steel is,
Yeah.
we are not doing a steel design. So this is for wind load and all that. So we are using BS 8110. Okay,
Yeah.
was that what was written there from the beginning?
Yes.
Like it changed.
Okay. Aren't we considering the wind load?
Wind load? No, you don't use wind load for this now. This is a small building now. This
Building,
is
okay.
just a one floor. This is just one floor.
Okay.
You start considering wind load once you are going up to 3 stories.
Okay. Okay.
Yeah. But it depends. It depends anyway. It depends. But Nigeria, we don't have much of challenges like that, except when you are going very high. If you are going very high, that's when you begin to consider wind load. When you are going up to 3 stories, but this is just one suspended floor. So, you know, when you are doing your design, it should not just be safety, but the economical aspect of it too. Your building has to be not just safe, but economical as well. So the allowable stress of soil, that's the soil bearing capacity. This one is gotten from soil test results. It's soil test reports. You must have gotten it from the soil lab. So from there, you'll be able to know. That means they must have gone to the site and took a sample of the soil there, and then they ran a test, and then whatever value you have there, you just, but Abuja have a very famous soil. So it's always falls within the range of, I think, 150, 200.
150. You just put the minimum at 150.
You said?
150 kilonewton per meter.
150.
Yes.
Yeah, I know. It falls within that range. Because Abuja and Kaduna, I think we have a firm soil. So our foundations are mostly pad. They are mostly pad foundations. Lateral drifts, I'm going to leave all of them as braced because we are going to be having walls around them. They are not entirely frame structures. So project header, you can just type in propose 5-bedroom duplex, 6-bedroom, 10-bedroom, whatever, based on whatever is given to you by the architect, or based on the location of the site rather, or the name of the project. So made by, you can type in your name, checked by the engineer who is going to check, or if you are the one doing your design and you are checking at the same time, fine. Project number, the project date. You type in all of that here, and then you click on OK. Okay. The concrete code selected has been changed. The selected code would have different, yeah. So okay, we are not considering any seismic parameters right now. Load combination, you have to click on loading generator, then also load cases, different load cases. Then this is the wind load you are talking about. But like I said, we are not considering wind load in this project. I think I have just like 10 minutes to round up this.
Okay.
That's the warning this is giving me. So I can click on building analysis. Check this, check this, check this, check this. But before that, I'll always advise you do your building model check. Look at it, building model check. And then you click on start. It's going to check the model if there are any errors. So building model check completed, number of errors is 0. So there are no errors. So I will close that. I will come to building analysis.
Yes.
Select. And I'll click on building analysis. So it's loading. I don't know if you are seeing it.
Yeah, but there's a black.
Yeah, I know. The screen is not showing it. You are not
Okay.
seeing it there.
Yeah.
Except I share the screen for you to see that
No
part.
problem. No problem.
Okay. So it has finished. Now you can see it's checking. Building analysis is checked green.
Yeah.
So it's done. Come to building. Now you can see some of the columns have failed. But it's not supposed to fail. I'm surprised. Okay. Sorry. I did not specify the reinforcement. So you can see here it's telling us 4Y12. Look at another one, 2Y13. So you cannot find even 2Y13 in the market in the first place. So I have to come back here and click on edit material, and I will change my reinforcement. For my column, I'm going to use just Y16 alone. For my beam, I'm going to also use just only Y16. These buildings are not large. For my slab, I'm just going to use only Y12. Then for my links, I'm going to use just Y10. So I think everything should pass now. Then I'll click on OK. Then I'll come back to analyze. Then I'll click on building analysis. I'll click here. I'll click check on this reselect bar, and I'll click. It's actually loading in the background.
Yeah.
All right. What happened? It's like I did. Shit.
Stick is still loading.
It's like I closed it while it was still analyzing.
And this session will soon be over.
Yeah. Okay, you are seeing it.
No, I'm not seeing it, but I'm just reminding you that because you said it like 8 minutes ago. It's almost 10 minutes.
All right, I will close it now. And
Okay, the remaining
okay,
meeting
I
time
think
is 2 minutes.
it has finished analyzing it.
Yeah.
Let me. I thought I closed it. I don't know. Is it that it's still analyzing or what?
This is
I think in 2 minutes time, this session will be over.
yes.
Let me just save this design. I'm going to close it and open it. So when we come back to the next one, we'll quickly import a drawing and design it quickly so that you can use that sample to do your design that you actually want to do. All right.